To perform a goodness of fit test in JMP, open up your data and then go to Analyze, Distribution. We will need to first construct a histogram by double-clicking on our data and putting it into the Y columns. Now, go ahead and click OK. From here, we can stack the distribution to make it easier on the eyes. With our distribution stacked, let's go ahead and fit a continuous distribution to it. Down here, we can go to Continuous Fit and select any distribution. For this example, we will be fitting a normal distribution. As you can see, this overlays a normal on top of the distribution. We have the mean from the summary statistics, and we also have the standard deviation, which tells us how spread out the distribution is. Our goal is to fit a distribution that fits really well on top of this histogram. With this in mind, we can check out the goodness of fit by clicking the red arrow and clicking Goodness of Fit. The goodness of fit tests as a null that the distribution is a good fit. As it says down here, the data is from the normal distribution. So this means our data comes from this red distribution right here. The alternative would be that the data is not from the normal distribution. As it says, small p-values reject the null hypothesis. With this in mind, our p-value is very small, and we would reject the null that the data is from the normal distribution. As you'll notice, there are a lot of outliers. We have a good many data points over here and a good many data points over here. While we would expect some extreme points, this might be a little bit too extreme. Also, there appears to be some skew in the distribution. If you'll notice, the median and Q3 are on top of each other, hence there is no line in the middle of the box plot. It does not appear to be normal enough to have come from the normal distribution. We can also look at the normal probability plot, known as a normal quantile plot. The normal quantile plot sees if our distribution follows a normal distribution by associating this straight line with the normal. The more deviation we see from the straight line, the less normal our distribution is. A very normal distribution will have the black points very close to the line. In our normal quantile plot here, we see a lot of the black points escaping from the line. We often associate this test with seeing if there's a bend. In mine, there does not appear to be much of a bend, so I might not know for certain with this if the distribution is normal or not, just from the normal quantile plot. What I can do to finalize my decision is look at the goodness of fit test, which tells me, reject the null that the data is normal. I have evidence it is not normal.